All right, ladies and gentlemen, we're working on the back side of the acid, base, and equilibrium review sheet, and we're just working on these few that period 6 had. If you want to see the other ones, you have to go to the part 3 of the video. So, if the pH is 6, what is the concentration of hydrogen ion? So first off, if the pH is 6, what is the pOH, everybody? Because these have to add up to 14. So now, if it's pOH is 8, the hydroxide ion concentration will equal 10 to the minus what? 10 to the minus 8. Hold on, just relax. Oh, did I get that wrong? It said for the hydrogen ion. Sorry, how embarrassing. So if this is pH is 6, well, okay, what would the hydrogen ion concentration have to be? 10 to the negative 6. Okay, more information than you wanted. The hydrogen ion concentration will be 1 times 10 to the minus 6. Thank you for being patient on that. 29 is our next one. A liter of impure water, so that's telling you it's got some solute mixed in there, has 1 times 10 to the minus 4 moles of hydroxide ions. That's OH. Okay, we've got 1 liter. Okay, so we've got this many moles in 1 liter. So that's just what our molarity is. We have a molarity of 1 times 10 to the minus 4. And let's see, that's hydroxide ions. So the question is, what is the concentration of hydronium ions in here? So hydroxide concentration is 10 to the minus 4. So what would then the hydronium, H3O plus, which is really just hydrogen ion, what would it have to be if this is 10 to the minus 4 for hydroxide? 10 to the minus 10. This would have to be 1 times 10 to the minus 10 moles per liter of hydrogen ion, because this and this have to add up to a 10 to the minus 14 over there. So if you figure out, if you know how many hydroxide ions you have in concentration, then you just add or subtract, so you get 10 to the minus 14. May I go on? Now, it's implied in this that when I'm going over this, you're following along, or you're working on something else. Is it number 29 we're doing? I just did that one, didn't I? Okay. What is the concentration of hydronium ions? That's H3O plus, and we're looking for this in a neutral solution. What is the pH of a neutral solution? 7. So pH 7, and that'll be 1 times 10 to the minus what hydrogen ions? To the minus 7. Have we answered the question? We have. In a neutral solution, pH 7, that would, if you do the reverse operation on pH, you end up with 1 times 10 to the minus 7. May I go on? No questions there? Number 36. Which of these solutions is the most basic? Okay. Well, what's the pH of this one? pH of 2. Now, okay, what's the pOH of this one? So the pOH of this is 13, so what would its pH be? 1. Okay, so now we got that. Let's come over here. We have a hydroxide concentration, so what's the pOH going to be here? Equals 4, which means the pH would have to be 10. Oh, thank you. Okay, not off the... And then over here, hydrogen ion concentration is this, so what's the pH going to be? 11. So now let's go back. Most basic. What's more basic? A bigger number, a bigger pH, or a lower pH? Bigger. We're looking for the most basic. We want the higher pH number, and is that going to be this one? Yep. That is the most basic, the least acidic. What is an acid-base buffer? It is a salt solution. Okay, we can do that. A salt solution, if you like. I'm abbreviating solution. That can act like an acid or a base. Can act like an acid. I'm just going to put capital A, or a base. So what that means is it's in equilibrium. If you add a little bit of acid to this buffer solution, it'll neutralize the acid, and the pH will try to stay the same. We got examples of it down below. We'll get to that in a moment. If you were to add a little bit of base, it would neutralize. What? Did I say something wrong? Thank you, ladies. They need to take a quiz. They're so stoked about the quiz. Hold on a second here. So come on over and get the quiz. May I go to 39B? Here you go. Take the quiz. Head up here. Don't cheat. Not that you would. What would the pH be after mixing about 7? Stay the same. Okay, I got to read the question. Oh, you're tricky. See, you have me do the B one, then I have to do the A. If you added a dilute acid, such as vinegar, to a pH 7.2 buffer, now that means this buffer wants to stay at 7.2. If we added a little bit of acid to it, so if we're adding acid to this, will that buffer act like an acid or a base in order to neutralize this acid that we add? It would have to act like a base in order to neutralize this acid. What would the pH be after mixing? So we started off the pH 7.2. We put in a little bit of acid. It neutralizes this. What will the new pH be? It'll be the same, assuming you didn't overrun the buffer's ability to neutralize. Number 40, if you added a little dilute base to soapy water, such as soapy water, to a pH 7.2 buffer, okay, again, we're trying to keep that at 7.2 pH. That's what the buffer does. What's the question? Oh, so you added some base to this. It will try to neutralize this base. Will it have to act like an acid or a base in order to neutralize this? It would have to act like an acid to neutralize that base. And after the mixing, what would the new pH be, assuming you didn't overtax the buffer? It should stay the same. So that's what buffers do. They try to keep the pH the same. Your blood is a buffered system. It tries to keep your pH the same. If you alter your pH, your body's blood chemistry has buffers that will try to neutralize it. If you get too much of it, like a lot of times in doctor shows, you hear them say, oh, he's getting acidosis, quick, blah, 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 blah. That means his blood's getting too acidic. It's exceeded the buffer capacity. Okay, enough of that. 41, what is the pH when the hydrogen ion concentration is 7 times 10 to the minus 3? Really? Wouldn't we have one over there? Okay, pH, hydrogen ion concentration. Okay, let's see. 7 exponent 3 negative. Okay, there's 7 times 10 to the minus 3. And look if it was just 1 times 10 to the minus 3, the pH would be 3. This is even more concentrated. It's going to be approaching probably a pH of 2, I'm going to guess. Let me see. Let me hit the log and change it around. 2.15. Well, yeah, it did exceed a pH of 2.15. There you go. There's the pH equals 2.15. Let me double check. Make sure I didn't hit the buttons wrong. Because always double check. Exponent 3 negative. Take the log of that. Reverse the sign. 2.15. I'm fairly confident now that I haven't pushed the wrong buttons twice. Can I go on to number 50? We still recording? Excellent. Okay. Which compound can act as both a Bronsted-Lowry acid and a Bronsted-Lowry base? Which one can act like an acid or a base? Water. In these reactions here, in this case, water was accepting a proton. Here it was donating a proton. Water is amphoteric, which means it can act like an acid or a base. What number was that? 50. So did I add which compound can act both as a Bronsted acid or a base? There we go. Number 52. Oh, I already did that one. Okay, so we're done, right? Just in case you were absent. You know what? I'm just going to zoom in on this. For the people that weren't here or period 4 didn't go over that. Well, we did. Ammonium donates a proton to this in order to make hydronium over here. So ammonium is the acid. This acts like a base. The conjugate of ammonium is ammonia. And since this one's an acid, this one's a base. So that's its conjugate base. We had the base of water over here. Its conjugate over here is hydronium. So that would make it the conjugate acid. And I will stop there. If I can hit the stop button. I never seem to be able to do this. Is that the right button? No. Okay, well, let's try pause. Is that the right button? Oh, you think I'd got this by now. Okay, record.